Hello and welcome to my demonstration of the relationship of the Panadent face bow. The face bows, ear bows, are related to an axis via an arbitrary relationship using the ear holes. So it's been calculated that the average axis is approximately 10 millimeters forward and 7 millimeters down from the auditory meatus or ear hole. The whole upper surface of the face bow represents your plane of reference. You can either use an orbital pointer by palpating the lower border of the eye and putting the spot on the side of the nose to choose your third point of reference, or you can standardize the system with a Nasion relator. Nasion relators, according to research, they say that the lower border of the eye is approximately 22 to 23 millimeters below Nasion. So you can see why the upper surface of the face bow represents the plane of reference. Now, usually when we take the face bow from the patient, we remove the bite fork assembly and go to the articulator for mounting the maxillary cast. But many people lose the relationship or how this has been engineered back over to the articulator. So I'd like to show you how we do this. Originally, face bows did not have detachable bite fork assembly, so you actually had to hook the whole face bow to the articulator. Since I don't need the Nasion relator because the upper surface of this face bow represents the plane of reference, that's all I need. Now we can come over to the articulator. I've removed the dyno links and we can now remove the upper frame. And the articulator also has an axis and a third point of reference, which is this flag, or also the bottom surface of the upper frame here. So we could actually hook this directly to the face bow by clipping one of the pins here on the side into the ear plug, and then clipping in the other side here on the other side. So I can tighten that into place there. The bottom surface here will touch the top surface of the face bow, connecting our plane of reference. You can also notice that the ear plugs are behind and above the axis, which is represented by the large hole here of the upper frame. So it would rotate around that point. So we could actually rotate this open and actually set it there and put a model in here, add some plaster and make a connection. But it's very awkward to set this on a countertop anywhere, so we like to have a little convenient mounting stand. So I'm going to use the articulator lower frame as a mounting stand. Now we could rotate this back, we could put in a model, add some plaster, and make a connection to the upper frame of the articulator. But since it has a detachable bite fork assembly, we can actually remove the incisal table, and I can add in the mounting fixture to the bottom of the assembly, tighten it in place, remove this bottom screw, and if everything's been engineered correctly, this should fall right down into that slot and forward into that slot, which it does, indexing this thing correctly. So I can add the screw back here. And now you can see how this has all been engineered through the upper frame, down through the lower frame, through the fixture, back up to the face bow. We could open the frame here, add a model, add some plaster and mount, but we really don't need the whole face bow here anymore, so I can actually loosen the screw and the thumb screw here in the front and actually remove the face bow from this apparatus. This is what would stay in the operatory, and only the bite fork assembly would come to the laboratory for mounting procedures. So we would basically detach this from the face bow, come to the mounting fixture, drop it in place, tighten the screw, add our model, and mount. Now if I set this incisal pin at 0, then when I close this frame down, the top of this pin should equal the bottom surface of this flag or the bottom surface of the upper frame here, which you can see it does. So you can see how this has been all engineered from the patient to the articulator. Thank you.